Okay, welcome to Chapter 1. This is, in Chapter 1, we're going to be looking at an introduction to statistics. I will say that Chapter 1 is not your typical math chapter. It's more definitions and concepts. So just bear with me and we'll get through this chapter and then we'll be ready to start into the math part of it in Chapter 2. Okay, some of our key concepts for this chapter, we're going to be looking at conducting a statistical study and how that consists of preparing your data, analyzing your data, and then finally drawing conclusions. So statistical thinking involves critical thinking and the ability to make sense of results. It's not as much calculation as a lot of math classes. So if you're afraid that you're going to be having a lot of complicated math calculations, that will not be the case here. It's more statistical thinking, critical thinking, common sense with that. Okay, so your first definition here is that of data, or some will say data, and it's the collection of observations. Some of these are different measurements. It may be gender, it may be survey responses like yes or no, male or female, Democrat or Republican, those type things. It might be your blood pressure, your pulse rate. It could be lots of different types of values, whether they're numeric or categorical data, as we'll talk about a little bit later. Okay, so statistics by definition is the science of planning studies and experiments, obtaining the data, and then organizing, summarizing, presenting, analyzing, and finally interpreting the data, and then being able to draw conclusions based on that. Okay, so why do we need statistics? The first one is just to be able to read and understand studies in your field. Maybe you're in nursing or psychology or whatever the case may be. There's going to be studies that are published that you need to be able to read and understand what they're saying. So that's the first reason that you're taking this class and studying statistics. The second is you may get so involved in it and that you want to actually conduct your own research and studies in your particular field. And then finally, even if the first two really don't apply to you, just being a better citizen and consumer. For instance, we're in the middle of an upcoming election this fall, and just understanding the polls that are presented and what they really are saying to us is very important. And studies that are released, you really need to understand the credibility that they have and so forth. So there's a lot that's important about statistics in terms of just being a better citizen and consumer. Okay, so another definition here is that of a population. A population is the complete collection of all measurements or data that's being considered. And this, typically a population is the complete collection of data that we'd like to make inferences about. Okay, so generally we're going to work in this class with samples, which are smaller than the population in most cases. And the population is what we want to be able to draw some kind of conclusion about. So we won't be able to study like every person in the United States, but we can draw a sample from that and study the sample and then infer something about the entire population. So the key word here with this is the word all. Okay, so with the population, you're talking about all the measurements that are being considered there. So populations can be large or small. As I mentioned, the United States residents, North Carolina residents, even college residents can be examples of populations, but populations can also be small. For instance, the business majors at Wingate can be a population, the football team at Wingate, church members of a particular church. All those are smaller populations, and oftentimes when the population is really small, then we just study everyone in the population. But then other times when the population is really large, we'll gather a sample out of that and study the sample and then make inferences about the larger population. Okay, so a census versus a sample. A census is when we collect data from every member of a population. So the key word there is every member. So every 10 years, there's an attempt in the United States to gather data from every single person in the United States. The United States population is so large that it's really difficult to do because some people are homeless, maybe they're moving from place to place, and they're not going to be counted, they're going to be missed. So a census for a very large population is very difficult to do. It's very time consuming. It's very expensive. So typically a census will start by doing a mailing, and then a certain percentage of the people will send theirs back, and that will be good. But then there's a certain percentage that won't, and they have to do follow-ups with that. Maybe it's another mailing. Maybe they send someone out to actually knock on the door and check with the people that live at a particular address. All of that gets very time consuming and very expensive to do. So that's why we don't work with a census very often. Instead, we work with a sample. And a sample is a sub-collection of the members selected from a population. So we pull this smaller group and work with it. And our hope is that we can pull the sample in such a way from the larger population that it is still representative of that population. So for instance, in gathering a sample of the United States, we wouldn't want everyone in our sample to come from California, or we wouldn't want everyone in our sample to be under the age of 18. So we want to make sure that our samples are done in a way that they do truly represent everyone in the original population. Okay, so here we have an example. It says in the journal article called Residential Carbon Monoxide Detector Failure Rates in the United States, it was stated that there are 38 million carbon monoxide detectors installed in the United States. When 30 of them were randomly selected and tested, it was found that 12 of them failed to provide an alarm in hazardous carbon monoxide conditions. So the question here is, what is the population and what is the sample? So if we look at this 38 million carbon monoxide detectors is going to represent our population. Okay, so that's the group that we're selecting from. That's our population. And then the sample is these 30 here. So the 30 were randomly selected and tested. So while it does appear that 30 is a small sample compared to the 38 million, if it's done correctly, that 30 could still be very representative of the population itself. Okay, and so that's just saying what I just went through and said there. Okay, one thing here, the objective is to use the sample data as a basis for drawing a conclusion about the population of all carbon monoxide detectors, and the methods of statistics are helpful in drawing such conclusions. So basically, what we're going to learn in this course is what's going to allow us to draw these conclusions. Okay, here's a practice one that I would like for you to look at. Identify the sample and the population that's described here, and then think about why would better results be obtained by observing the hand washing instead of asking about it. Okay, if we look at this, our sample here would be the 1,046 adults that were surveyed. Excuse me, yes, that were surveyed here. Our population would be all adults because it really doesn't specify any particular group of adults, so our population would be all adults. So in this survey, the 1,046 adults are representing all adults in the study. As far as why would better results be obtained by observing the hand washing instead of asking about it, people just don't always answer truthfully in a situation like this. So we'll talk a little bit later about how it's good for the person conducting the study to be the one that records the data instead of asking people to self-report. Okay, so we'll be looking at statistical and critical thinking. First of all, we're going to look at preparing our data. We'll talk about the context of the data, the source of the data, and what sampling method we're using to gather the data. Then we're going to look at graphing the data using histograms and some other various types of graphs. Explore the data. Look at kind of, are there missing data values, those type things, and then apply different statistical methods to it. And finally, determine, do we have any type of statistical or practical significance with that. Okay, so as far as preparing our data, one of the context questions that we want to consider is, what does the data represent? So if I just tell you the number 97, we don't really know what 97 is. It might be 97 inches, it might be 97 beats per minute. We don't know. So you have to give some context to the data that's presented there. In this case, it represents the pleasure boats and that are involved in pleasure boats and the manatee fatalities from these boat encounters. So that's what the data represents here. Okay. Does a relationship exist between the data? So in looking at this, we're trying to see, does a relationship exist between the pleasure boats and the manatee fatalities? So as we have more pleasure boats, do we have more manatee fatalities with this? So that's important as far as understanding the relationship between that. So the source of the data, it's important with the source of the data for it to be a credible source. And generally, if it's funded by the government or it's funded or conducted by universities, those sources are considered credible. So in this particular case, the data was from the Florida Department of Highway Safety and Motor Vehicles. So we would assume that's a fairly credible source. It's not a source that stands to gain anything by conducting the study. They're just basically there to report what we see. So they do appear to be fairly reputable. How's the data gathered? This one was gathered from official government records, and so we would assume that that would be reliable. And so it does appear to be a sound sampling method. Okay, I want to talk about voluntary response samples because a voluntary response sample, sometimes called a self-selected sample, is one where the respondents themselves decide whether to be included. So in some ways, I think self-selected sample is a better indication of what this really is. If you're selecting yourself to participate, then it's a voluntary response sample. And the reason that it's important to know this is because voluntary response samples are not going to be credible samples. They often have a serious flaw. They're going to have a serious bias simply because people only participate in these when they have a very strong response. For instance, if there was some type of social question about abortions, the people that would respond to that question are the people that feel strongly either for or against abortion. It's not going to be the people in the middle that are going to take the time to respond. So basically, we, for the most part, discredit voluntary response samples just because of the bias that's introduced due to the way that the samples are gathered. Okay, so some examples of voluntary response samples would be internet polls. You see these pop up and people can give their opinions. People are deciding to participate, so therefore it would be a voluntary response and not very credible. Mail-in polls, that would be an example. Telephone call-in polls. So like if you're watching the news and there's some type of poll that you can call in and participate in, then that's going to be a voluntary response. Those where they call you are not voluntary response. Okay, so you've already been randomly selected by some kind of computer program. So even though you do to a certain extent decide whether you participate or not, you're not initiating the participation in the study. And so therefore, for it to be the telephone call in would be where you initiate the study. You initiate the participation in the study, and therefore it's voluntary. Okay, so I've got two scenarios here. The first one is Nightline asked viewers to call with their opinion about whether the UN headquarters should remain in the United States. Viewers then decided themselves whether to call with their opinions, and 67% of the 186,000 respondents said that the UN should be moved out of the United States. So the second scenario is in a separate independent survey, 500 respondents were randomly selected and surveyed, and 38% of this group wanted the UN to move out of the United States. So the question is which one is going to be more accurate? So I'll give you just a minute to think about this and then we'll look at what your response should be. Okay, so when we look at the two polls, the first one, and I'm going to go back to this so we can talk about the details here. The first one has a large number of participants, 186,000, but this is actually the least accurate because the viewers are calling in with their opinion, so it's a voluntary response, and therefore only those that have a strong opinion about the UN headquarters are going to be participating. And so even though we get the 67%, it's done in a way that's flawed and therefore biased, and it's not really going to give us the best results. So this one is much smaller, but because it was conducted randomly and it was representative of all the people that of all people, then we would have the 38% of the group that wanted the UN to move out of the United States. So 38% would be a more accurate representation for that. Okay, so after completing the preparation by considering the context, source, and sampling method, then we start to analyze the data. And in analyzing the data, part of that will be through graphing and exploring that we'll look at in Chapter 2. One thing I wanted to point out here is a good statistical analysis does not require strong computational skills. A good statistical analysis does require using common sense and paying careful attention to sound statistical methods. So it's really important to use your critical thinking skills for this. Okay, I want to look at statistical versus practical significance. So to start with, statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. So we do have a cutoff here for statistical significance. It needs to be that it occurs by chance 5% or less of the time. So basically, if it's occurring, is it very rare for it to occur just by chance alone, is what we're looking at for statistical significance. So it would be extremely unlikely just to happen by chance. Okay, so this is kind of an example here. Getting 98 girls out of 100 random births would definitely be statistically significant because we know that that would be a rare event for that to happen. And therefore, if it did happen, it would be very unlikely for it to happen. So here we've got 52 girls in 100 births. That would not be statistically significant because we know that if we're going to have 100 births, we're going to have around 50 girls, give or take a little bit, and therefore it's not unlikely for it to happen just by chance. Okay, so practical significance, we don't have a number that's a cutoff for this like we do with statistical significance. Basically, put yourself in that situation and just think about using common sense. Is the treatment or finding convincing enough that you would want to take part in it? For an example of that might be if you, if you were going to participate in some type of study about losing weight, and in doing that, maybe after a year's time, you would be guaranteed to lose 2 pounds. So, would that have practical significance? Would you want to stay on a diet for a year if you're only going to lose 2 pounds? So, that's just something to put yourself in the practical side of it and make sure that it makes practical sense. Okay, so here we have ProCare Industries once supplied a product named Gender Choice that supposedly increased the chance of a couple having a baby with the gender that they desired. So in the absence of any evidence of its effectiveness, the product was banned by the FDA as a gross deception of the consumer. So suppose that the product was tested with 10,000 couples who wanted to have baby girls, and the results consisted of 5,200 baby girls born in of the 10,000 births. So the result would be statistically significant because if we ran the statistical numbers on this, the likelihood that we get 5,200 baby girls out of 10,000 births is actually only about 0.003%. So chance would not really be a feasible explanation for getting 5,200 baby girls out of the 10,000 births. So it is statistically significant because the chance of it happening is less than 5%. But if we think about this, that's still about 52% of the births being girls. So from a practical significance standpoint, it actually is not practically significant because 52, we would expect about 50% being girls anyway. So 52% is not that significant of an increase, cause people to want to go through the process and spend the money that it's going to take to participate in this gender selection process. You have to look at statistical significance, look at the number, compare the likelihood of it being less than 5%. Practical significance, put yourself in that situation and consider whether it would be worthwhile. Okay, so here's an example. In a study of the Kingman Diet and Exercise Program, 40 subjects lost an average of 22 pounds. There's about a 1% chance of getting such results with a program that has no effect. Determine whether the results appear to have statistical, practical, both, or neither significance. So it can have both, it can have neither, or it can have a combination of the two. So here we look at this 1% chance. So the 1% chance is less than 5%. So I automatically know that it's going to have statistical significance. Okay, so at the practical significance, I'm going to think about this. Okay, in the study, they lost an average of 22 pounds. So is it something that is enticing to people to want to be part of a diet that's going to lose on average 22 pounds? And for most people, I think they would participate in a diet where they lose 22 pounds. So in that case, it would have practical significance. Practical significance, I do think, has a bit more of a gray area to it than statistical significance. Just put yourself in that situation, think about it from a common sense perspective, and I will try to give you some that are pretty clear cut one way or the other with the practical significance part. Okay. Okay, so some pitfalls when we're analyzing data. When you can draw some misleading conclusions. A lot of times when forming a conclusion based on a statistical analysis, we should make statements that are clear even to those who have no understanding of statistics in its terminology. So, like, you might have a situation where you have where we say correlation does not imply causation. And I think an example of that would be ski rentals, because as ski rentals goes up, ice cream sales goes down. So they are correlated. There's a relationship between the two or a correlation between the two, but there is not a it's not a causation situation. So ski rentals going up does not cause ice cream sales to go down. It just so happens that because of the weather, that's what's happening. We need to be careful that we don't jump from a correlation relationship to trying to imply a causation relationship. Another example is there's been some studies that says vitamin D levels may keep you from having such severe COVID symptoms. But while we may be seeing a correlation between the two, we can't really establish a causation effect there. Um, Sample data needs to be reported, and it's better to take your measurements yourself instead of asking subjects to report the results. Okay, so with this, like an example of this would be people's weight. If you ask people what their weight is, and they're not going to necessarily tell you the truth about it, and it would be better for you to measure the data yourself instead of having people self-report. So other examples might be people's like IQ or their height, how much they make, any kind of thing where people might have a reason to fabricate or lie about things would be an example of where you need to not have people self-reporting and actually go ahead and measure for yourself. Okay, loaded questions is another example of a potential pitfall that you can encounter here. Sometimes survey results are not worded carefully and results can be misleading. So if we look at this, it says, would you like for Wingate University to add more class options? So a lot of people would respond that they would like for Wingate to add more class options. But then if we add some more words to it, it says, would you like for Wingate University to add more class options if it will be paid for by raising tuition to cover the cost? So by adding these additional words, we kind of load the question and create a bias from that. So even though it's probably true in both situations that it would be paid for by raising tuition to cover the cost, by adding this additional information, you definitely will slant the response that you get from students participating in the question. Order of questions can sometimes be create a bias as well, even unintentionally. So like in this example, it says, would you say that traffic contributes more or less to air pollution than industry? Because traffic was mentioned first, it had a much larger percentage than industry. If you turn that same question around and say industry before air pollution, sorry, industry before traffic, then you get traffic first and then industry with that. Okay. And then non-response is when you have people that just simply refuse to participate or are unavailable to participate in your study. So maybe you randomly select them from a computer and then you call them and they refuse to participate. So non-response can play a part in these surveys. Percentages, one thing, be really careful. Your percentages should not exceed 100%. So if you're referencing something that exceeds 100%, then it's not going to be justified. Also, 100% of some quantity is all of it. So just keep that in mind as well. Okay, so I have a couple studies here for you to look at. So I'm going to pull them up. I would suggest pausing them, reading them, and then listen to what I say about what's wrong with those. Okay, so on this particular one, I'm not going to read it because you can read it, but if we look at this, a couple things here, they're going to be paid by a law firm that intended to sue vaccine manufacturers. So there's a self-interest there by the law firm, and therefore that would be a problem with the study. Obviously, falsifying medical histories would not be appropriate to do as part of a study. The 12 cases is a very small number of cases, so that would be problematic. And then they're unable to replicate the findings. That is going to be a problem as well. Because in a good study, somebody else should be able to go and follow the procedures and replicate their work. Okay, this one would definitely be biased because by adding the part about Sweeney had a car crash while driving under the influence of alcohol, that is going to be a loaded question that's going to impact people's opinion about the congressional candidate. And by including that in the question itself, then it's a loaded question and does create a bias. Okay, on this one, we've got a situation where correlation does not imply causation. So looking at this, the study only demonstrated that a correlation existed between whole grain foods and heart disease. We really don't know which is the cause and the effect in that, but when the results were published, it stated that the whole grain foods actually reduced or had an effect on the risk of heart disease, which is not what the study actually established. So we need to be careful that we only report what is truly established. Okay, are the results of this survey valid? The answer there would be no, because this was a voluntary response sample, and therefore a bias was created because of that. Okay, with this one, there's actually two problems. One is the author is having the students self-report, and therefore they may just write down what they would like to be as far as their height. We don't really have any way of knowing if it's truthful. The other thing is he wants it in inches, and a lot of people don't know their height in inches. They know it as feet in inches, and they may not be able mathematically to make that conversion. Okay, that takes us to the end of section 1.1.